This is the 2.6 lecture. We'll see how far we go. If we cruise through this fast enough, this will also include 2.6 problem set to give you some examples. 2.6 starts on page 145. I'm actually going to start on page 146. Top of the page, using the associative property. In 1.5 we went over the associative property, and what that basically meant is that if we take any two numbers and multiply them, we can, well, let's use a number other than 1. 4 times 2 is the same as 2 times 4. So you can switch those numbers around and multiply them in different orders. It's not a problem to do that. You still get the correct answer. So what we're doing is we're going to not only review, but we're also going to go a little bit further and start using some variables. If you remember, a variable is a letter that represents a number. So if you hear me use that term variable, that's all I mean, is there's some letter out there that represents a number, and that's what we're using here. So let's try a multiplication. Let's do 7 times 3a. A is our variable. It's the number that we don't know. According to the associative property, we are multiplying 3 different items here. A 7, a 3, and an a. Well, we can't multiply a 3 times an a because we don't know what the heck the a is. But we could multiply the 3 times the 7 and get 21. So we get 21a. So instead of 3 things that are being multiplied, 7 times 3 times a, we actually can multiply the 7 and the 3. Now if you remember, PEMDAS says we have to do what's in the parentheses first. Well, we can't do anything in there. That gives us the option to go outside the parentheses, and in this case we can take 7 and 3 and multiply it and get 21a. So actually the way it really works is you can multiply pretty much anything. If you have a 7 and a 3a, you can multiply the two numbers here and just tack the a onto the end of it with your 21a. If you're given something like -2 times 5x, you can, like we said earlier in multiplication, a negative times a positive gives you a negative, and we tack the x on there. So that's using the associative property, which also, let's do a couple other things here while we're in this section. Let's take 3 plus 8 plus x. Alright, that's using addition. Instead of the associative property of multiplication, let's use the associative property of addition here. And that says the same thing. Doesn't matter what order you add these in. So we look at the 8 and we look at the x. We cannot add these because we don't know what number that is. So can't be added. But we can add the 3 and the 8. We know what that is. That's 11. Well, we add the 3 and the 8, those disappear, and we're left with our plus x, since we couldn't do anything with it. And that's our answer. That's just simplified. It's not, we didn't find out what x was, so we didn't solve it. There's no equal sign there. All we did is simplify it, made it easier. Alright, let's look at another one, such as 2x plus 5. Put that in parentheses to show that we have to do that first, and then put a plus 10 here. Well, we look at our parentheses, we can't do anything with it. You can't combine a 2x and a 5 again because we don't know what the x is. So how do we add these two when we don't even know what this is? So we combine what we do know what is. We do know that we can add a 5 and a 10. So our 2x we leave alone since we can't do anything with that, and we put a 15 here, and right now we have that simplified and we're good to go. That's as far as you can go with it without knowing any other information there. Which brings us to the bottom of page 146, called Using the Distributive Property. The distributive property was introduced in chapter 1, and I'm going to use numbers. They use a bunch of letters, but it's a lot easier when you use numbers. I'll just use one letter here. 4 times the quantity, x plus 5. Now if you remember, what the distributive property says is if we have a number or a letter or anything outside the parenthesis, we can multiply it by each term in the parenthesis. And let me let me define term here for what we're doing at this point. That definition will get more specific later, but let's stick with the definition that it's a number or a letter separated by a plus or a minus sign. So this particular one has two terms inside the parentheses, the x and the 5. So we have two terms. So we're going to multiply this 4 times everything in here. That's what this says, 4 times this stuff in here. Well, we can't multiply 4 times this stuff, so what we're going to do is we're going to multiply the 4 times each term. So 4 times x, well, we can't multiply 4 times x again because we don't know what x is, so we're just going to pull them together and just leave it. 4 times x. That's as far as we can go. Now we're going to do the next one. 4 times 5, which is 20. It's positive 4 times positive 5. So that plus sign is going to stay there. So we're going to bring our sign down, multiply times each term, and we get 4x plus 20 for this one. Let's look at some other ones. Very similar to 2 times x minus 3. Same thing. Distribute. 2 times x, can't do anything, so it's just 2x. 2 times 3 is 6. Bring down our minus sign, and we're done. Alright, so let's try just one real quickly on your own. I'm going to write it up here, give you a few seconds to kind of think through, write it down, and see what you can come up with as far as that answer. So go ahead and either do it out loud or write it down. Probably feel pretty silly doing it out loud, so just like I feel silly talking to myself. Alright, so when you're done you should have gotten 20x plus 12, because we took 4 times 5x and got 20x, 4 times 3 got 12, plus sign came down, and we're good to go. Alright, what if we had 5 times 2x plus 3y. Well, we've got our parentheses. According to PEMDAS, we're supposed to do what's inside the parentheses first. Problem is, with like terms, you can't combine those. You can't add or subtract terms unless they're alike. And one of the key things that makes a term like is if the variable, the letters, are the same. If they're the same, we can combine these. If they're different, we cannot combine those. So, we cannot do anything inside here. All we can do is distribute. So we're going to take the 5 times the 2x, and we're going to take the 5 times the 3y, and we're going to bring our plus sign down, and that's as far as we can go. Can't go no further. Okay? So that is using the distributive property. Alright, the next section is called similar terms. And similar terms is basically what I said earlier as far as like terms. You cannot combine an x and a y or subtract. You can combine these two because they are like terms. They have common variables. Well, when you have 3x plus 4x, it's kind of like saying 3 quarters plus 4 quarters, 7 quarters, or 7x. Okay? So you can combine those. When it says add, you add the whole numbers, stick the x on there. You don't do anything with the x's, just like you don't do anything with the quarters. 3 quarters plus 4 quarters is 7 quarters. 3x plus 4x is 7x. So those are like terms or similar terms according to the book. And which brings us to algebraic expressions representing area and perimeter. I'm going to do that on the next video, and then we'll go from that video right into problem set 2.6. So go ahead and turn this off, go to the next video for the rest of the lecture, and then I'll go over some on 2.6.